Hey there, that thing you're watching this on right now? It's literally millions of times more powerful than the very first computer. And that first one, well, it was the size of a room and weighed a whopping 30 tons. So today, we're going to unpack how that incredible transformation happened. Let's dive in.
Yeah, that's the big question, isn't it? How did we get from a 30-ton monster that filled an entire room to the smartphone you're holding in your hand? It's a story of, well, incredible shrinkage, but also this unbelievable explosion into every single corner of our lives. So how on earth did we pull that off? Okay, so our story kicks off in the middle of the 20th century. And forget about sleek silicone chips. We're talking about an era of massive, roaring machines that people literally called giant brains.
All right, let's meet the first big one, ENIAC. That stands for the Electronic Numerical Integrator and Computer. When this thing debuted in 1945, it wasn't just a new machine. It was a totally new kind of machine. See, it was the world's first general-purpose electronic computer. And what that means is you could actually reprogram it to solve different kinds of problems, not just one. And let me tell you, it was an absolute beast. So what made it tick? Well, this number right here is the heart of ENIAC. We're talking 17,468 vacuum tubes. Just think of them like little electronic switches, almost like fragile glass light bulbs that controlled the flow of electricity. The problem? They got insanely hot and they burned out all the time. Can you imagine trying to find the one broken bulb in a chandelier that has almost 18,000 of them? It was a nightmare. And it wasn't just the tubes either. The whole system, the whole shebang, weighed 30 tons. It filled a massive room. It was loud, it was a power hog, and it was so ridiculously complex that if you wanted to reprogram it, you had to physically rewire its circuits. A job that could take days. But, for all those problems, ENIAC was an absolute miracle of speed. The newspapers weren't wrong when they called it the giant brain. I mean, it could crunch numbers in seconds that would take a human mathematician weeks to figure out. It was used for everything from calculating military trajectories to forecasting the weather. And it proved, for the very first time, that a single machine could be programmed to tackle a huge range of different problems. So after ENIAC, its successor, UNIVAC, took things to the next level. Think of it this way. If ENIAC was the wild, groundbreaking prototype, UNIVAC was the first model that was actually ready for the market. It's the machine that brought computing out of the military labs and into the business world. And its first big customer, the US Census Bureau. But owning one? Yeah, that was a whole other story. A single UNIVAC unit cost up to $1.5 million. In today's money, that's over 18 million bucks. So yeah, only the biggest of the big institutions could afford one. But this was the real start of the commercial computing era. Now, here's a really important part of the story. These giant machines, they were just hardware, just metal and wires. To make them actually do anything, they needed software. And the people who created that software, they were true pioneers whose stories, unbelievably, were almost lost to history. Meet the 6 brilliant women who were ENIAC's very first programmers. I mean, just think about this. They were working without any manuals, without any programming languages. None of that existed yet. They had to figure out, from scratch, how to translate incredibly complex math into physical instructions for this giant machine. They basically invented modern programming. They came up with fundamental concepts like subroutines, reusable blocks of code, and debugging, the process of finding and fixing errors. I mean, these are things we still use every single day. And yet, for decades, their absolute genius was overlooked. It's just such a crucial reminder that it's always people driving innovation, not just the machines themselves. Okay, so the era of the giant brains had, well, a giant problem. They were just too big, too fragile, and they devoured way too much power. The world needed a revolution. And that revolution, it came in a very, very small package. So here was the bottleneck. Those thousands of hot, fragile vacuum tubes, they were holding technology back. It was that simple. For computers to ever get smaller, faster, and more reliable, the vacuum tube just had to go. And the solution? It arrived in 1947 at Bell Labs. It was called the transistor. And it did everything a vacuum tube could do, but it was solid state, it was tiny, it was reliable, and it used just a fraction of the power. This one invention was the key. It was what unlocked the entire future of smaller, faster, more powerful computers. And the transistor?
It started a chain reaction, like a set of dominoes. First, in 1958, we get the integrated circuit, which crammed a bunch of transistors onto a single chip. Then came the really big leap in 1971, the microprocessor. This put the entire brain of a computer, the CPU, onto one single chip. And with each step, computers got exponentially smaller, faster, and cheaper. They were finally ready to leave the lab.
So, this relentless shrinking of technology set the stage for the final act of the revolution, taking the computer out of the giant corporation and putting it right into our homes. And there were two machines that really led the charge here. First, the Apple II in 1977. It went after families with its user-friendly design and, wow, color graphics. Then, 4 years later, you have the IBM PC, which targeted the office. Its secret weapon was its open architecture, which basically meant anyone could build hardware and software for it. And that created this massive ecosystem that just completely took over the business world. And this is why it all mattered so much. The personal computer, it democratized technology. It completely changed the game, redefining who could use a computer and what you could even use it for. Suddenly, the power to create, to calculate, to communicate, it wasn't locked away in some corporate data center anymore. It was on your desk. So let's connect all these dots, right? This entire incredible history, from those giant brains to tiny microchips, it's your digital inheritance. It's the reason why you, right now, have a literal supercomputer sitting in your pocket. So let's just recap this incredible sprint. We start with the room-sized ENIAC in 45. Just 2 years later, bam, the game-changing transistor. By 51, UNIVAC is taking computing commercial. And then the revolution goes personal. The Apple II hits homes in 77, and the IBM PC transforms the office in 81. I mean, think about that, from one giant brain to millions of computers in homes and offices in just a few decades. So you go from a 30-ton giant to a supercomputer in your hand, all within a single human lifetime. That unbelievable pace of change really makes you wonder, doesn't it? What on earth will the next 75 years bring? Now, the material for this explainer was drawn from the book Homo-Servus, The Collapse of Human Sovereignty in the Digital Era, written by Doctors Wahiba Malawi, Mubarak Muhammad, and Halima Malawi. You can find their book on Amazon, and you can learn more at homoservice.org. Thanks so much for joining us.